key lesson. I can't tell you guys how important this lesson is, because here's the reality with radicals. All right, so we're going to, and we did this in pre-algebra, and we're going to review it all here in algebra. With radicals, we have to add them, subtract them, multiply them, divide them. We also have to solve equations that have them. And in all of those aspects, we have to simplify them. So today's lesson on simplifying will affect you when you add radicals. It will affect you when you subtract radicals. It will affect you when you multiply radicals. It will affect you when you divide radicals. And it will affect you when you do radical equations. Pretty much everything with radicals, you have to understand the aspect of simplifying. And so just like we told you last chapter, the first key of factoring is factor out common factors. But I said you have to be careful because you don't always have common factors to factor out. Every time you add radicals, will there be simplifying radicals? No. Every time you multiply radicals, will you be able to simplify? Not necessarily. Every time you divide radicals, will you be able to simplify? Not necessarily. Every radical equation, will you be able to simplify? Not necessarily. But I'm telling you, when you can, you have to. And so this is foundational. It's really important that you try to understand the concepts of what's involved in simplifying radicals. I don't think they're hard. So if you'll just hang in there and try to understand the concept, and you need to ask questions. If in the course of this lesson you're not sure what's going on, you need to ask, and I'll try to explain it in a little bit different way to try to get you to understand it. All right, the first aspect is this product property. All right, it shows that factors of the radicand can be separated into distinct radicals. Factors of the radicand. So you can see our radicand has an a times a b, right? We have the right to separate it. Now you got to keep your index. So I'm going to take my green and put a green N as the index. And I'll put the A in the front as the radicand, and I'll put the B in the back. We really, in effect, have factored this radical. Now here's something I'm going to say a lot the rest of the course in algebra. Last chapter we learned how to factor polynomials. Factoring is a means to an end. In other words, you learn factoring so you can do some other things. Now on the test, the end answer was the factoring. Why? Because we first have to teach you how to factor so you can then do the other things we're going to need to teach you and show you. But you shouldn't become factor happy. You don't take a normal answer and factor it. That would be silly. For example, let's suppose you were solving a problem and you got an answer, don't write this, an answer of 10. Would you then say, oh, I need to factor, let me write my answer as 2 times 5? You wouldn't do that, would you? Why would you all of a sudden factor your answer? It was a 10. Matter of fact, if you had 2 times 5, we'd want you to say, hey, that's a 10. We'd want you to multiply it out. Factoring is a means to an end. And right now, doing this factoring, the product property is a means to an end. It's going to allow us to do something. If it allows us to get somewhere more simple, then we want to use it. That's the concept. That's the idea. I know that's hard for you guys in the beginning, and it doesn't sink in right away, so I'll keep trying to mention it so that hopefully it will get to you. All right, let me show you the practicality of the property. Here we have the square root of 4x. Well, here's what the property says. We have the right to separate that into the square root of 4 times the square root of x. You can separate it. And everybody knows the square root of 4 is, so where do we end up with? 2 times the square root of x. Now again, we've done these in pre-algebra, but it's been a while, so we got to shake out all the cobwebs and See if we can remember and understand what in the world's going on. So it was to our advantage to factor that, because we can take the square root of 4. The second example, same situation. This one's a cube root. We'll separate it into the cube root, and we'll do a 27 times the n squared. Can you take the cube root of 27? Yeah, it's a 3 because 27 is 3 times 9, and 9 is 3 times 3. So the cube root of 27 is 3. Can you take the cube root of n squared? And the answer is no. We could turn it into a fraction if we wanted to, but that form's no better, and we just leave it as a radical. So you end up with 3 times the cube root of n squared, and that's your solution. We are at a more simplified answer than we had originally, and that's what we're after. Getting as simple as we can. So this factoring concept allows us to get more simple. So here in our third example, the square root of 45. Now you just got one number. That's not a 4 times a 5, it's a 45. Anybody have a good idea on how to split this thing up? Well, I chose, a decent number here. John? Say again? An 8 times 5? Nah, that won't work. Josh? How about a 9 times 5? Now you can go 3 times 15 if you want, but that won't help us. But what if we go a 9 times a 5? Because hopefully you agree 9 times 5 is 45, right? Again, if you don't understand, a 45 is a 9 times 5, and we can split it up. And the reason we want to choose 9 and 5 instead of 3 and 15 is we can take the square root of 9, that is a 3, and so we end up with 3 times the square root of 5, a more simple result. And that's what we're after, simplifying. We want a more simple result. Okay? More simple result. All right, so let's look at the next aspect. Here's the concept of factoring. Whenever the number of factors equals the, anybody know what goes in the blank? Index. Next time you guys will raise your hand for me. You'll know when I'm asking the class. I always give you an indicator there. All right, so whenever the number of factors equals the index, the root is that factor. Okay, so look at A. The index is not shown. Jeff, what's the index? No. Gavin, what's the index? 2. Whenever the index is not shown, the index is 2, and it's a square root. What does the index tell you about the root? In other words, what are square roots? Kyle? Okay, so a square root, a 2 index, says what number times itself 2, the index, 2 times equals the radicand. If I had a cube root, an index of 3, it would be what number times itself 3 times equals the radicand. Okay? So here's the reality. Whenever the index matches the exponent, what times itself 2 times is an n times n? The answer, an n. That's the reality. If you want to think of it as square roots undo squares, you can think of it that way. But again, what's a square root? What times itself 2 times is an n times n? An n times itself 2 times is an n times n. In the next example, you have a cube root. What times itself 3 times is a 7 times 7 times 7? Answer, a 7. Excuse me. A 7 times itself 3 times is a 7 times 7 times 7. In our last example, you got a couple parts. You got the 5. What times itself 5 times, or 4 times, is a 5 times 5 times 5 times 5? Answer, a 5. And the second part, What times itself 4 times is a y times y times y times y? And the answer is a y times itself 4 times is a y to the 4th. So that's the basic concept. So look, let me try to get you to understand. Square root, we're looking for 2 of the same factor. And the root is that factor. The end. Cube root, we're looking for 3 of the same factor. Whether it says 7 cubed or 7 times 7 times 7, we're looking for 3 of the same factor, and the cube root is that factor, that's 7. For a 4th root, we're looking for 4 of the same factor, and the 4th root is that factor, that 5, or that factor, that y. That's what you're after. That's all we're doing. Okay, so let's now, questions before I go farther. Questions. All right, we'll find out in a minute. So simplify the following. First one's easy. Get rid of my shade so I can go higher. All right, first one's pretty easy. What's the, well, maybe not, right? So, Jeff, what's the index of A? 2, right? We're doing a square root. So if you want to think of it like this, I'm going to use my red here. What is an x cubed? An x times x times x. Do you agree? Can you take the square root of x times x? Yes or no? Yes or no? Can we take the square root of x times x? We can. So if we were to use the rule, then what we would do is we would separate it out, and we would write like this. Don't write this, or you can if you want. We would write like that, right? So what we would write, we would take the square root of the x squared, and we would end up right there, right? It's what we just did a minute ago, daydreamers. Not going to know what to do. However, honestly, you can just do it right at the radicand. So I'm going to do it in red right here without this step. Because we know it's true, we can do it right here. You guys remember RBUM, reduce before you multiply? Because we knew everything's going to end up underneath one fraction bar, numerator, denominator, we could just do it beforehand. And it's the same way here. You don't need to physically split it all up. We'll just do it here. So what's the square root of x times x? It's an x. And what do I have left? I have this last x underneath the radical sign left. And that's really all you're doing. And x times the square root of x. Just dealing with what's left. Look at the next one. Let's do a couple, and then I'll take questions. And if you have questions along the way, I'll take them as well. So I'm looking at this 40. Anybody know the cube root of 40? I don't. It's not an even number. But what are factors of 40? 2 and 20, right? 4 and 10, right? You want to go 4 and 10? Let's go 4 and 10. I'll go for your sake. Could have gone 5 and 8, John, now. 40 instead of 45. But I'll go 4 and 10. And we know what 4 is a 2 and a 2. And we know what 10 is a 2 and a 5. Does anybody see anything we can take the cube root of? And you should all hopefully see the 3 2's. Whenever you have as many factors as match the index, the root is that factor. What is the factor? A 2. I just took the root, so I crossed it out. I took the root. Now I'm going to do the n's in blue. Look, don't we already have as many n's as match the index? So what's the cube root of n cubed? N. Anything that you take the root of comes out in front of the radical. In this one, we still have a 5 left in. So I still have to write the cube root of 5. There's nothing we can do with that. We don't want a decimal round off, so we got to leave it the cube root of 5. 2n times the cube root of 5. We simplified it. We took the root of everything we could. That's what we're after. Taking the root of everything we can. Taking the root of everything we can. Taking the root of everything we can. So that's the concept. That's the idea. I'll do one more and I'll leave the last one for you guys. So 56, I'm going to use my red here. I'm going to look to factor, right? It's all about trying to find factors that I can take the square root of on this one. Let's see, 56, 7 times 8. You may not have used 7 and 8. Doesn't matter as long as you use correct factors. And usually on something like this, an 8 is a 2 times 4. Now, you can further factor the 4 into 2 times 2, but class, doesn't everybody know the square root of 4 is what? 2. So you can do it right there if you want. Here, I'll use green for my a cubes. How many a's do I want to be able to take the square root? How many? 2. I have 3. So how about if I make it a squared times a? Does that make sense? And what's the square root of a squared? Say it if you know it. A. So an a's out. Now the b to the 4th, you can 2 ways. You can use the rule we learned, right? B to the 4, its exponent over the index 2, which would be a b squared, right? That works when they're multiples of the index. Or you can factor it into a b squared times a b squared, right? I'm trying to factor it into things that match the index, yes? I have a 2 index. I want to factor it into squares. So what's the square root of b squared? B. What's the square root of the second b squared? Another b. And now I got to look at what's left. Now, again, you got to be neat here. You guys that are sloppy and your stuff's all over the place, it's going to be hard. I have a 7 and a 2. That's a 14. And I have an a. Clean up my front 2ab squared times the square root of 14a. That's what you guys are doing today. Trying to simplify as much as you can. And it's all about the index. You got to find stuff you can take the root of. All right, try D. Try that cube root. See what you can do with D. Are you there? Again, it's new, so it's going to take you a little bit longer than what it should. But you're looking for 3 factors. Normally, I would stop at 27 because I know the cube root of 27 is 3. But why is the cube root of 27 3? Because a 27 is a 3 times 3 times 3. What's the cube root? It, a 3. What am I going to do with my n to the 5th? I'm going to go n cubed. Remember, I'm trying to get 3 of them to match my index. How many are left? N squared, right? What's the cube root of n cubed? N. That's out. What am I going to do with my y's? I'm going to go y cubed. There's 3 of them. Y cubed. There's 6 of them. Y squared. There's the other 2 of them to make 8 of them. Cube root of y cubed. Y. Cube root of y cubed. A second y, so I'm going to square it. What's left in? Don't forget your index. Cube root. I have the number 2. I have an n squared. I have a y squared. How many got that correct? Okay. And how many got at least a part or 2 of it correct? Okay. So again, you just got to be careful. Don't make a mistake. Notice what I do with the variables. Because you have to know what your index is. This is what tells you what to do. A 3 index, I'm looking for 3 things. With variables, you're going for cubes. You know, a y to the 8th is a y times y 8 times. So I use 3 of them. I use 3 of them again, 6 to the 8. The last is 2 left, y squared. If you can't do that, you can just write out the 8y's, I guess, but that'll take you forever. Questions. Questions. Everybody's got it perfectly. All right, next page. All right. Let's see, for time's sake, let's just do F. Go ahead and do F. I'll give you a minute, and then I got to interrupt you. See if you can get it in a minute. All right, guys, for time's sake, see how far along you are. I wouldn't even factor this, but I'll just show you guys. The first factor is 3 times 4, 2 times 6. Am I going to get 5 of any number? So I'm not going to waste my time anymore. There's not going to be a simplifying of the numbers. Matter of fact, I would have never started because I knew I wasn't going to get a 5 of anything. Some of you wouldn't have realized that right off the bat, but hopefully you get to one point and say, oh, there's not going to be 5 of any single number. So the number's not going to simplify. All right, variables. How many am I after? I'm after 5. So my first thing is, I want that to be green, my first thing is a to the 5th. I used up 5 of the 10. Hey, I got another 5 left. So I use the a to the 10th. What's the 5th root of a to the 5th? A. What's the 5th root of this a to the 5th? A second a. A times a is a squared. All right. Let's do my b's. All right, got to go b to the 5th. Used up 5 of them. B to the 5th again. There's 10 of them. B to the 5th again. 15 of them. How many's left? 2. 5th root of b to the 5th. B. 5th root of b to the 5th. B squared. 5th root of b to the 5th again. Another third. Another b. That's b cubed. And I look at my c's. Are there enough c's to do anything with them? Nope. That's it. Everything's left inside. 5th root of 12. All my a's are gone. B neat. My b's are b squared. And my c's are c cubes. Right? I mean, you're just trying to find as many factors as match the index. That's all it's about. That's all it's about. It's that easy. Once you get the concept down, you're looking to match the index. How many get that right? All right, bunch of you guys. Good. And if not, hopefully you notice, or maybe you just ran out of time because I'm going fast here at the end. All right, last thing, number 4. Remember, you take the root of, this is key in red, factors of the radicand. Factors are things that are multiplied. What is an a minus b quantity squared? Well, really, it's an a minus b times an a minus b. What times itself 2 times is an a minus b times a minus b? Answer, a minus b. Right? The answer to this is simply a minus b. Again, you can think of it as square roots undo squares if you want to think of it that quickly, and you can. But it's the whole quantity. You know, in B, what is this? This is a 2x plus 5 quantity times a 2x plus 5 quantity times a 2x plus 5 quantity. So what is the answer? The 2x plus 5. Cube roots undo cubes. Okay, well, those were easy because the index matched the exponent, right? Let's look at our last 2 examples. Here's what students want to do. Everybody look. This is a big mistake. The square root of n squared is n, yes? Why is that a mistake? That's wrong. And you got to know why. Anybody know why that's wrong? Anybody know? Josh. Exactly. It's being added to the 2n, which is being added to the 1. This is one quantity. And you can't take the n squared by itself. We had the same principle involved with reducing fractions that had polynomials, etc. It's the exact same situation. This is all one thing. Don't make that big mistake. Now, what if instead you tried to factor the radicand? Oh, it's a trinomial. I'll use trial and error. I'll make the front n times n is n squared. In the back, you know what? Positive 1 is my only possibility is plus 1 and plus 1. I'll do my check. Outers is a 1n, plus inners is another 1n, and that gives me the middle of 2n. Oh, I factored it correctly. What's the square root of n plus 1 times n plus 1, class? N plus 1. See, I'm now able to take the square root because I have something times itself. The whole radicand is now factors, not just a part, because that n squared is added. So look at this last one. Oh, that would have been a great example. All right, I'm out of time. You'd have to factor that radicand. You have the homework listed there for you. Go ahead and get that done tonight. Quiz tomorrow. Quiz tomorrow. Quiz tomorrow.